This recording is for PreCalculus Unit 5, Lesson 5, Solving Exponential Equations. So let me get a screen on which to write here. Okay, so I've got three problems I want to demonstrate for you. They'll represent three of the major techniques that are used in this lesson. Do make sure you go through all of the examples in the lesson and do some practice exercises, because there's quite a bit of material in this lesson and I can't cover it all, obviously. So here, first question I would like to do here is this one, 5. Let's color here, 5 times 7 to the x equals 20. This is an exponential equation where the variable is in the exponent. Okay, so one of the techniques here is to isolate the exponent. So I'm going to divide both sides by 5. And now we have a pure exponential equation, and we can convert that to a logarithmic equation. Remember, log base 7. The answer to a log is an exponent here, so the exponent is x, so the argument is 4. Log base 7 of 4 equals x. Log base 7 of 4 equals x. You can kind of create a circular pattern here. Log base 7 of 4 equals x, to rewrite this as an exponential, or as a logarithmic. Okay, and now we know what x is. X is the log base 7 of 4. Now there is a conversion unit, or a conversion method. In Desmos, you can find the log base 7. But in most calculators only have log base 10 and log and base e, the natural log. So in that case, you can convert this to another logarithm this way by doing log base 10 of 4 divided by log base 10 of 7. And that works for natural log as well. Natural log of 4 divided by the natural log of 7. So if you want to find the log base anything you want, just divide by the log of that base, and you'll have your answer here. So let's pull up Desmos. Desmos.com. Okay, get rid of that. All right, graphing calculator, and I'll demonstrate first how to find the log base 7. So log base underscore 7 of 4. Okay, and then log of 4, this is log base 10 when I don't designate the log, divided by log base 7. Notice it's the same one. The natural log of 4 divided by the natural log of 7 is also the same. So you can verify that all of these work. All right, so there we have it. So it's about 0.712. 0.712. Okay, so that's the first exercise, or first example I want to give. All right, so solving for an exponential and then turning it into a logarithmic equation, and then using that to find the decimal approximation. Okay, so another example here. Here we go. Let's do this one here. 9 to the x equals 7 to the x plus 1. Okay. You may notice here that we have a little bit of a problem in that we've got different bases, so we can't just go around turning this into a logarithm equation, because we have exponents with different bases involved. Okay. Now the trick here is actually to, well, there's a couple of tricks. I'm going to show you two techniques here, but one technique is to take the log of both sides. And I'm going to use the natural log. I'm a calculus teacher. Natural log tends to be used more often than log base 10. It really doesn't matter which one you use. Ln 7 to the x plus 1. And now we're going to use the exponent rule for logarithms. The exponent comes down in front. The exponent comes down in front. Okay. So the exponent comes down in front. We get x ln 9. And then x plus 1 ln 7. Now we've got an equation I can solve. I'm going to distribute the ln, the natural log. So x ln 9 equals x ln 7 plus ln 7. Now I'm going to subtract x ln 7 from both sides, basically getting the x's to the left side of the equation. So this is x ln 9 minus x ln 7 equals ln 7. Factor an x out. Ln 9 minus ln 7 equals ln 7. X now equals, divide by ln 9 minus ln 7. Ln 7 divided by ln 9 minus ln 7. Okay, and we can get a decimal approximation using Desmos. Ln 7 divide ln 9 minus ln 7, and about 7.74. Okay, I said I was going to show you another way here, and this will just be real quick here. It is possible to use rules of exponents. 7 to the x plus 1 is 7 to the x times 7. Now if I divide by 7 to the x, I get 9 to the x divided by 7 to the x equals 7. And now I've got a single logarithm, 9/7 to the x equals 7. And it is possible now to convert this to a logarithmic equation. Log base 9/7 of 7 equals x, right? And just to check here, let's see if this works here. So the log base 9/7, I'm going to use Desmos' capability to do base 9/7, base 9/7. Nope, it's got to be a whole number. It'll only do a whole number. So we're gonna do the conversion formula. So log of 7 divide log of 9/7. Okay, and there we go, 7.7429. So it's the same answer here. Just to give you an alternative. It is possible to isolate it down to a single exponent in this case. Not always, though. All right, so that's case number 2. Case number 3 is one that can confuse people, so pay close attention to this. The idea is recognizing that we're dealing with a quadratic equation. Okay, so this one is e to the 2x, minus 6e to the x minus 27 equals 0. Now we're going to use the power of powers rule, and that says that e to the 2x is the same as e to the x squared, right? Multiply the exponents, you notice it comes out the same. Minus 6, I'm going to put this in parentheses, e to the x minus 27. Okay, and I'm going to say let y equal e to the x. And then we get y squared minus 6y minus 27 equals 0. And notice the quadratic, right? We can solve that by factoring or by completing the square or by quadratic formula. This one happens to factor y minus 9, y plus 3. So y equals 9 or y equals negative 3. Now go back to what y is. Y is e to the x. So e to the x equals 9 or e to the x equals negative 3. Now e to the x is a function that takes off flat and takes off like an airplane like this, right? Where this is the x-axis. It does not ever go negative, so e to the x cannot be negative 3, so we're going to eliminate that possibility. And we're going to solve e to the x equals 9. Well, ln, or log base e, log base e of 9 equals x. So x is the natural log of 9, and we can crunch that on our calculator. Ln 9 is 2.197 or 2.20. Okay, And so 2.20 solves the equation. So the key here was recognizing the quadratic form.